Hello students, this is grade 9 physics class, chapter 8 motion. In last video class we have seen the velocity time graph. Am I right? What is that? Velocity time graph, yes. In this session we will start a next topic. In velocity time graph, next topic. Is it clear? Yes. So in order to start our next topic, we must recall what are the things we have seen in previous video class, because the previous video class posted a few days before, a long days before, maybe so more than 1 week. Okay, you may have forgot that. That is the reason why we must recall. Is it clear? Yes. So what are the things we have seen in previous video class? That is velocity time graph. Am I right? Velocity time graph. Yes. First of all, what is velocity time graph, sir? Why do we need velocity time graph? Isn't it? Yes. See, for example, theoretically, so we can find out, theoretically and numerically we can find out the acceleration, a velocity, a distance, a displacement, and so many things. Suppose that calculation is given by graphical, which means graphical method. Can you find it easily without any teaching method? No, we cannot find that. Yes. Okay, so to find out, to calculate what is velocity, acceleration, a distance, a displacement, so many things, by graphical method we need the graphical representation of motion. Graphical representation of motion. Is it clear? Yes. So we have two types of graphical methods. First one, the distance time graph, and second one, velocity time graph. Okay, yes. The distance time graph already completed. Then last class we have just started the velocity time graph, isn't it? Yes. This velocity time graph work under five conditions of the motion of the object. How many conditions? 5 conditions of the motion of the object. So what are the conditions, sir? First one, when an object velocity changes at uniform rate. Second one, when an object velocity changes at non-uniform rate. Isn't it? Yes. Third one, now we are going to start that. The third one, what is that? When an object velocity remains at constant. What is that? Remains at constant. That is third one. Then fourth one, when an object velocity decreases, note this point, decreases at uniform rate. And fifth one, when an object velocity decreases at non-uniform rate. What is that? Non-uniform rate. Okay, under those conditions, this velocity time graph work. Okay, totally 5 conditions are there. In previous video class, we have completed 2 conditions. First 2 conditions completed. Am I right? So what are the conditions? First one, when an object velocity changes at uniform rate, we have completed. Next, second one, when an object velocity changes at non-uniform rate, we have completed. Is it clear? Yes. But in this session, we will start our next condition of the velocity of the object. Okay, which means generally we say motion of the object. That is, when an object velocity remains at constant. What is that? Remains at constant. Is it clear? Yes. First condition, what is that? When an object velocity changes at uniform rate. Isn't it? What is that? Uniform rate. So whenever in velocity time graph, the velocity of the object changes at uniform rate, there will be straight line. Am I right? There will be straight line. This straight line shows what is the velocity of the object, uniform rate. Okay, velocity of the object, uniform. This straight line shows. Is it clear? Yes. Come to first one. So in velocity time graph, whenever the straight line is inclined, note this point, straight line is inclined to the time axis, which means x axis, we can say, what is that? That motion is called uniformly accelerated motion. Note this point, very important. One more question. Whenever in velocity time graph the straight line is inclined to the time axis, or otherwise we can say x axis, that object is at, what is that? Uniformly accelerated motion. We can say the object is at uniformly accelerated motion, or otherwise we can say uniformly accelerated motion, that is. Is it clear? Yes. Second one, come to second one. That is when an object velocity changes at non-uniform rate. Note this point, non-uniform rate, that is second condition. Is it clear? Yes. So in second condition, that graph will be curved line. Am I right? The graph will be curved line. Is it clear? Because it's not a uniform rate, that is non-uniform rate. That is the reason why there will be curved line. Is it clear? Yes. Look at this. Look at here. In velocity time graph, whenever that line is curved line, note this point, that line is curved line, that is called, what is that? Okay, we can say that the object is at non-uniform acceleration. Note this point, the object is at non-uniform acceleration. Okay, so finally come to the point, what are the 2 points? So in velocity time graph, whenever the straight line which is inclined to the time axis, which means the x-axis, we can say that is uniformly accelerated motion. On this point, uniformly accelerated motion. And second condition, whenever in velocity time graph the line is curved line, we can say the object is at non-uniform acceleration, that is called non-uniformly accelerated motion. Non-uniformly accelerated motion, that's all. Both are very, very important one mark question. Is that clear? Yes, very simple. Okay, yes. This velocity time graph also used to find out 2 quantities. Am I right? 2 quantities. So what are the 2 quantities, sir? First one, acceleration. Velocity time graph is used to find out acceleration of the object. And second one, what is that? Yes, displacement. The magnitude of the displacement covered by the object during particular interval of time. So, with the help of the velocity time graph, we can find out acceleration, and second one, magnitude of the displacement, or otherwise we can say magnitude of the distance. Here, the distance, displacement and area both are same meaning here. Don't get confusion. Okay, in velocity time graph, the distance, displacement and area all are same meaning. You don't get confusion. Is it clear? Yes. So, till now we have seen up to this. Am I right? Till now we have seen up to this. Next, in velocity time graph, the slope, that slope shows what is that? In velocity time graph, the slope of the object shows that, what is that? That is acceleration of the object. Because velocity time graph is used to find out only acceleration as well as displacement. But that slope only shows what is that? That is acceleration of the object. Acceleration of the object. Okay? Is there any doubt? No doubt. I hope there will be no doubt. Okay? Yes. So in velocity time graph, just 5 conditions are there. Already we have completed 2 conditions. I am going to start in this session the 3rd condition. What is that? 3rd condition. Is it clear? Yes. So what is 3rd condition, sir? You may ask me, what is 3rd condition, sir? Yes. So when an object velocity remains at constant, or this point remains at constant, that is 3rd one. Okay? Yes. Let's get started. So 3rd condition of velocity time graph, what is that? Velocity time graph. Yes. What is 3rd condition? 3rd condition velocity time graph, when an object velocity remains at constant. So when an object velocity remains at constant, that is 3rd condition of this velocity time graph. Is that clear? Yes. So already you know what is constant, sir. What is constant? Constant means nothing but there will not be any change. Okay, there will not be any change, that is constant. Here there is no change in velocity of the object, that is constant. Am I right? There is no change in velocity of the object, that is called constant. That is called constant. Is there any doubt? No. Yes. Yes, obviously we will start with the example, because this is very complicated lesson. Without the example we cannot we cannot get any idea about any topic. That is the reason why whenever I start any new topic, I will start with, what is that? Example. Okay? Yes, so here also I am going to start with the example. So consider, so 3rd one, what is that? When an object velocity remains at constant. Is it clear? Yes. Suppose you and your father have decided to make a trip by a car. Okay, so you and your father decided to make a trip in a car. Is it clear? Yes. Your father starts the car. Actually, so you are in front seat. front seat. Is it clear? Yes. Your father starts the car speed gradually increases. Note this point. The car speed gradually increases. Here, what is speed? Speed means velocity, because this velocity time graph is also known as speed time graph. Is it clear? Yeah, here speed means what is that? Velocity. So that car speed gradually increases. But you have a stop clock. You have a stop clock to measure for what? To measure the velocity of the car during particular interval of time. During particular interval of time. That is the reason why you have a stopwatch. Is it clear? Okay, you start again. You and your father decided to make a trip in a car. Your father starts the car. You are in front seat. You are in front seat. Yes. Your father starts the car. That car speed gradually increases. The car speed gradually increases. You have a stop clock to measure the velocity of the object, which means a car, during particular interval of time. Is it clear? Yes. So the velocity of the car gradually increases. Look at here. When the car attains the speed of 40 km per hour. Note this point. When the car attains the speed of, here what is speed? Velocity. Yes. When the car attains the speed of 40 km per hour, you suddenly start on, which means turn on the stop clock. Turn on the stop clock. Now what is the initial velocity? You tell me. What is the initial velocity? Yes, obviously that is 40 km per hour. That is initial velocity. Time 0. Time here 0, because at 40 km per hour speed, you just turn on the stop clock. So stop clock time 0. Stop clock shows time 0, not a 1 second, any other second. Stop clock shows only 0 second. So at 0 second, what is the velocity? Initial velocity? Yes, 40 km per hour. 40 km per hour. Okay, this is very, very important concept. Keep that in your mind. Okay, yes. Okay, so let's start with that. Consider a car. Consider a car. Okay, consider a car. This car is here. Consider the car is at position A. The car is at position A. Position A. So what is the initial velocity of the car here? Initial velocity of the car 40 km per hour. Yes, initial velocity 40 km per hour. So you may ask me, sir, velocity unit meter per second, sir. Why you have written like a kilometer per hour? See, velocity, SI unit, that is meter per second. Bigger unit for our convenience, we have choose whatever it is. But SI unit meter per second. For our convenience, I have taken in kilometer per hour. That is not a wrong. That is not a wrong. Okay, yes. Car initial velocity 40 km per hour. That car initial velocity how much? 40 km per hour. So at point A, that car velocity how much? 40 km per hour. Is it clear? Yes, very simple. Don't get confusion. Yes. In next 1 hour. So here what is the time? Here time 0 seconds. Here time 0 second. At 0 second, the velocity, initial velocity of the car 40 km per hour. 40 km per hour. Is it clear? Yes. In next 1 hour, note this point. In next 1 hour, the velocity of the car. Okay, what is the time? Next 1 hour, the velocity of the car remains same. What is that? Remains same, which means in next 1 hour also the velocity of the car 40 km per hour. Same 40 km per hour. Okay, yes. Even next to 1 hour also, look at here. So now the car comes to point B here, the point B here. Okay, after 1 hour. Yes, now the car is here. I'm ready. Yes. From the point B, note this point. From the point B, in next to 1 hour here. In next to 1 hour, the car velocity remains same. Remains same, which means just 40 km per hour. Remains same. There is no change in the velocity of the car. So the car comes to position C. The car comes to position C. Is it clear? Yes. From the point C, note this point. From the point C, in next 1 hour, again the car velocity remains same. How much? Yes, 40 km per hour. 40 km per hour. Is it clear? Yes. Now the car comes to point D here. Point D here. Is it clear? Yes. Look at here. From the point D, in next 1 hour, again the car velocity remains same. Again the car velocity remains same, that is 40 kilometer per hour. 40 kilometer per hour. Is it clear? Yes, look at here. In equal interval of time, okay, in equal interval of time, the car velocity remains same. Is it clear? Car velocity remains same. Am I right or wrong? Yes, obviously right. Look at here. The car initially at point A, so at point A the initial velocity of the car 40 km per hour times 0, yes. In next to 1 hour, note this point, in next to 1 hour the car velocity remains same, that is 40 km per hour. That is 40 km per hour, which means the car still moves at constant speed, constant velocity. Am I right? Yes. So now the car comes to point B. From the point B, in next to 1 hour, again the car velocity remains same. Again the car velocity remains same, that is same 40 km per hour. Same 40 km per hour. Isn't it? Yes, there is no change in velocity of the object. Yes. Next, from the point C, know this point, from the point C, in next to 1 hour, which means 3 hours, in next to 1 hour, again the car velocity remains same. Again that car velocity remains same at rate of 40 kilometers per hour. Okay, yes. From the point D, from the point D, in next to 1 hour, again the car velocity remains same. So whatever the time, the velocity of the object remains same, remains constant, that is 40 km per hour. There is no change in velocity, but at different, so times change here. At different interval of time, which means different interval, time here, time interval equal, but first 1 hour, second 1 hour, third 1 hour, fourth 1 hour, the velocity of the object remains same. There is no change in velocity of the object. That is called constant acceleration. Okay, see, look at here. You may have get some doubts about the uniform acceleration, uniform velocity and this constant velocity. Am I right? In uniform, okay, which means that uniform acceleration, the velocity of the object increases uniform rate. Note this point, in uniform acceleration, the velocity of the object increases uniform rate, but in constant, the velocity remains same. Look at here, 40 km per hour. Remains same, but in uniform acceleration, the velocity increases uniform rate. Note this point, velocity increases uniform rate. Okay, am I right? Yes, first interval of time, the velocity it may be 10 meters per second, next 20 meters per second, next 30 meters per second, next 40 meters per second. Okay, in uniform acceleration, but in constant, whatever the time, the velocity remains same, that is 40 km per hour, that is constant. Okay, I'll explain Tamil. நீ கான்ஸ்டன்ட்டையும் யூனிஃபார்ம் ரேட்டையும் குழப்பிக்க கூடாது. யூனிஃபார்ம் ரேட்னா அங்கே யூனிஃபார்மாக இன்க்ரீஸ் ஆகுது, சேஞ்ச் ஆகுதுன்னு அர்த்தம். ஆனால் கான்ஸ்டன்ட் அப்படின்னா அங்கே சேஞ்சே இல்லை, கண்டினியூஸாக அதுலேயே போயிட்டுருக்குன்னு அர்த்தம். புரியுதா? நீ யூனிஃபார்மையும் கான்ஸ்டன்ட்டையும் கன்ஃபியூஸ் பண்ணிக்க கூடாது. யூனிஃபார்மில் என்னது? யூனிஃபார்மில் அங்கே யூனிஃபார்மாக சேஞ்ச் ஆகுதுன்னு அர்த்தம். அங்கே சேஞ்ச் இருக்குது, ஆனால் கான்ஸ்டன்ட்னா இங்கே சேஞ்ச் கிடையாது, கண்டினியூஸாக அதுலேயே போயிட்டுருக்குன்னு அர்த்தம். புரியுதா? எஸ், தட்ஸ் ஆல். ஓகே, எஸ். So what is the interval here? Velocity interval 40 km per hour, whatever the interval you take, here the interval will be 40 km per hour. Am I right? Yes, your time also, that will be 1 hour, isn't it? Yes. Look at here in equal interval of time, here the velocity of the object remains at constant. So whatever the time, the velocity remains at constant. On this point, the velocity remains at constant. Is it clear? So that is known as when an object velocity remains at constant. So first 1 hour the object velocity 40 km per hour, second 1 hour the same 40 km per hour, even next 1 hour the 40 km per hour, last 1 hour also 40 km per hour. Is it clear? Yes. So whatever the time, the velocity of the object remains constant, that is 40 km per hour. There is no change in velocity. That is called constant velocity. Note this point, that is called constant velocity. Is it clear? Yes. So in this situation, what will be the acceleration, sir? That is next question. Okay, so at constant velocity of the object, what will be the acceleration of the object? That is very big question. Next we will find out that. Is it clear? Next we will find out that. Is it clear? Yes, very simple. So with the help of this example, I am going to make a tabular column. Okay, which means data, graph data. Okay, yes. Time in seconds. Next, velocity in kilometer per hour. Sorry, time in hour here, because I have taken in hours. Am I right? Yes. Time in hour. Next, velocity in kilometer per hour. Kilometer per hour. Is it clear? Yes. First time, what is the time, sir? Sorry, here, not a second, hour, because I have taken hour, yes. So first, at 0 time, what is the initial velocity? Yes, 40. Here, initial velocity not 0. Next, 1 hour, 2 hour, 3 hours, and 4 hours. Okay, then what is the time here? Yes, same 40 kilometer per hour, same 40 kilometer, even next 1 hour also 40, last 1 hour also 40. So whatever the time, the velocity of the object remains same, which means remains constant, that is 40 kilometer per hour. There is no change in velocity. That is called constant velocity. That is called constant velocity. So you look at here, uniform velocity and constant velocity, both are not same, not similar. Okay, uniform means what is that? Their velocity changes at uniform rate. But constant means what is that? Constant means there is no change in velocity, still that object moves with constant velocity. That is concept. Okay, yes. So I have made a tabular column, okay, which means graphical data with the help of this example. With the help of this example. Is there any doubt here? No doubt. Look at here, very simple. I again repeat it. In first interval of time, the car maintains the velocity, that is 40 kilometer per hour. Next 1 hour also the car maintains the velocity, the same 40 kilometer per hour. In next 1 hour also the object maintains the velocity, same 40 kilometer per hour. In last 1 hour also the object maintains the same velocity of 40 kilometer per hour. So whatever the time the velocity of the object remains same, that is called constant velocity. That is called constant velocity. Is it clear? Yes. So with the help of this example, I have made a tabular column, which means the graphical data. So with the help of this data, I am going to plot the graph. Look at here. Okay, you pause the video and write the all notes. Okay, because I am going to rub this one. I don't have space here. Okay, yes. So I am going to rub this. So I am going to plot the graph with the help of this data, this graphical data. I am going to plot a graph. Okay? Yes, listen here. Yes. So we always take time along a x-axis here. Yes. Time in hour, x-axis, and this is y-axis, and velocity in y-axis. Yes. Velocity in kilometer per hour. What is that? Velocity in kilometer per hour. Yes. So this is 0, center point. This is x-axis, this is y-axis. The time is taken along a x-axis. And time rate how much? 1 hour, 2 hour, like that. Okay, yes. So this is 1 hour, 2 hour, 3 hour, 4 hours. 1, 2, 3, 4. Because time is taken along a y-axis in hour. Sorry, x-axis, sorry for that. Next, then velocity is taken along a y-axis in kilometer per hour. Is it clear? Yes. So this is a 10 kilometer per hour, 20 and 30, and this is 40. Is it clear? Yes. So next, plot the all points. Okay, which means mention the all points in velocity time graph. Okay, yes. Look at here. At 0 time, what is the velocity? So time 0 here. What is the velocity here? Velocity of the object 40 km per hour. Am I right? Yes. So this is 40 is here. So 40 km per hour. At 0 time, the velocity of the object 40 km per hour. And 1 hour, first 1 hour, what is the velocity here? Yes, same 40 km per hour. Same 40 km per hour. Yes, make that same 40 km per hour. Yes. Your next 1 hour. Next 1 hour also, what is the velocity of the object? Okay, which means here. What is velocity of the object? Same 40 km per hour. Yes, here. Same 40 km per hour. Isn't it? Yes. Even next to 1 hour, which means third one. Next to 1 hour, what is velocity of the object? Same 40 km per hour. Yes, like this. Mention that 40 km per hour. Am I right? Yes. In last 1 hour, what is the velocity of the object? Yes, same 40 km per hour. There is no doubt. Same 40 km per hour. Is it clear? Yes. I have mentioned the all points with help of this velocity time graph data. That's all. Yes. So look at here, the all points are there. Next, I am going to connect the all points. I am going to connect the all points. Look at here. Yes. It will be like this. The graph will be like this. Yes. The graph will be like this. Okay. This is straight line. Can you see this clearly? Yes. This is a straight line. Am I right? This is a straight line. Okay. Yes. Next, come to the point. This is x-axis, which means time axis, because we have taken a time along y-axis in velocity. Is it clear? Yes. So this is velocity time graph for when an object velocity remains at constant. When object velocity remains at constant. This is third condition. Is it clear? Yes. So in this condition, the velocity time graph will be straight line. I mean this way. Look at here, the velocity time graph shows straight line. This is straight line. Can you see this? Yes. This straight line is parallel to the time axis. Isn't it? This is a straight line. Velocity time, this is a straight line. This straight line which is parallel to the x-axis. Am I right? So this line parallel to this line. This is time axis. This is time axis. This means x-axis. This is time axis. The time axis which is parallel to this. So both are parallel to each other. So whenever come to the point, it's a very, very important one more question. In velocity time graph, whenever the straight line is parallel to the time axis, note this point, parallel to the time axis, we can say the object is at constant velocity. What is that? Constant velocity. Is it clear? So very, very important one more question. Even already we have seen in first condition. What is the condition? When an object velocity changes at uniform rate. At uniform rate. So in that case also, that velocity time graph would be, what is that? Straight line. Straight line, yes. So whenever the straight line which is inclined to the time axis, like this, I'll draw here. Look at here. Like this. Okay, this is for first condition. This is for first condition. What is this condition? This graph for first condition. What is the condition? When an object velocity changes at uniform rate. Am I right? So uniform rate, it will be straight line. So this is x-axis, this is y-axis. This is for first condition. Don't get confusion. This is not for this one. Okay? Yes. In velocity time graph, the straight line which is this is inclined to the time axis, we can say that is uniformly accelerated motion. Uniformly accelerated motion, or otherwise we can say the object is at uniform acceleration. Uniform acceleration. Am I right? But come to here. This is also straight line. Okay, this also straight line, but the straight line which is parallel to the time axis. Am I right? Parallel to the time axis, which means x-axis. So we can say here the object at constant velocity. Constant velocity, or otherwise we can say constant speed. We are both are same here. Is it clear? Yes. Come to the conclusion. Whenever in velocity time graph the straight line is parallel to the time axis or x-axis, we can say the object is at constant, which means the velocity of the object remains constant. The velocity of the object remains constant. That's all. Very, very important one more question. Okay, what is that? So whenever in velocity time graph the straight line is parallel to the time axis or x-axis, we can say the velocity of the object remains at constant, or otherwise we can say the speed of the object remains at constant. Both are same, no problem. Is there any doubt? No doubt. Okay. Can you catch my point here? Yes, that's all. Okay, after that I'll explain Tamil. Okay, yes. So if we connect the all points, we can get the straight line. The straight line which is parallel to the time axis, which means x-axis. We can say the object velocity remains constant here. Remains constant. Yes. So what about the acceleration, sir? What about the acceleration? Because the velocity time graph which is used to find out the acceleration, here what is the acceleration? That is very big question here. That is very big question, isn't it? Yes. Next we are going to calculate the acceleration. What is that? Acceleration of the object. Okay, yes. What is the acceleration of the object? At the velocity remains constant. Okay, during the velocity remains constant. Is it clear? It's very simple. Okay, so next I'm going to find out what quantity? Acceleration quantity. After that we will find out magnitude of the displacement. Is it clear? Yes. So here consider any 2 point here. Consider from this 4 points, 5 points, 1, 2, 3, 4, 5 points, you consider just 2 points. Just 2 points. Okay, any 2 points. Okay, I'm going to consider this one and that one. Okay, so this point and that point. Okay, so consider this is A and this is B. Okay, yes, from the point A, note this point, from the point A, so draw a line which is parallel to the y-axis. Okay, this is y-axis, draw a line from the point A parallel to the y-axis like this. Yes, can you catch my point? Yes, so this is y-axis and draw the line. Okay, draw a line which is parallel to the y-axis from the point A here. Yes, we can get like this, like that, isn't it? Yes, consider. Next, from the point B, look at here, from the point B, draw a parallel line to the y-axis like this. Okay, this is point B. So from the point B, draw a line which is parallel to the y-axis like this. Yes, can you see this? Okay, I'll use color chalk piece. Okay, yes, this one, this line and that line. That line. Is it clear? Yes. Next, I'm going to give the name for that. This one, the AB, and this one C, and this one D. Okay, and the AB for that is velocity, and CD for that is a time interval, because here these two lines connect in a particular time interval. Okay, so that's why I have given a name for that, the AB, CD. Is it clear? Yes. Look at here. So now I am going to find out what quantity. You tell me what quantity I am going to find out. Yes, acceleration quantity. Okay, yes. So I need space. I am going to rub that. You will look at here. So I am going to find out what is that next one? Acceleration. Yes, acceleration formula. What is that? Acceleration formula, what is that? Yes, acceleration which is equal to final velocity minus initial velocity divided by time taken. Am I right? Acceleration which is equal to final velocity minus initial velocity divided by time taken, that is equal to acceleration. Is it clear? Here which is final velocity and which is initial velocity? Which is final velocity and which is initial velocity? You tell me. Why? Because here we have two quantities. Isn't it? We have two quantities here, A and B. Here which is initial velocity and which is final velocity? Yes, B is a final velocity, A is a initial velocity. Am I right? B is a final velocity, A is a initial velocity. Is it clear? Yes. What is the time here? Time? Yes, T2. Sorry, this is the final time. This is the initial time. Okay. So look at here. This is initial. This is the final velocity. So V. Color chalk piece. I'll take color chalk piece. You can see clearly. So this is final velocity and this is initial velocity of the object. Am I right? Yes. So this is time T2 and this is T1. Which is T2? 3 hours is T2 and 2 hours is T1. Is it clear? Yes. Now you find out the acceleration. Acceleration which is equal to final velocity minus initial velocity divided by time taken, that is acceleration. Am I right? Yes. So here, okay, here what is the final velocity? This is B is the final velocity. What is the B value? Yes, that is 40 km per hour. Am I right? Yes, B value, final velocity value 40 km per hour minus initial velocity. U is initial velocity, which means A is initial velocity. A value same 40 km per hour. Yes, 40 km per hour divided by time taken. Here we have two time interval, T2 minus T1. Am I right? Yes, T2 minus T1, which is equal to 40 km per hour minus 40 km per hour divided by T2 value how much? T2 3 hours. 3 hours minus T1 value 2 hours. 2 hours. So which is equal to how much? 40 km per hour minus 40 km per hour, which is equal to, what is that? Yes, 0. Here 0. and divided by time value 1 hour. So what is the acceleration? You tell me. What is the acceleration? So here numerator 0. Am I right? Numerator 0. So what is the value? What is the value? You tell me. 0. Acceleration of the object 0 here. Whenever an object moves with constant speed or constant velocity, acceleration of the object 0. That's all. That is the concept. Acceleration of the object, yes, 0. Here acceleration 0. That's all. Why? Because initial velocity 40 km per hour. Final velocity also 40 km per hour. So final velocity minus initial velocity, that is acceleration. So 40 km per hour minus 40 km per hour, that is equal to 0. So acceleration of the object 0. That's all. Yes. So look at here. So here acceleration of the object 0. Is it clear? Yes. See here, what is the conclusion, sir? Here, what is the conclusion? Note this point. Note this point, very, very, very important, one more question. Whenever an object moves with constant speed, note this point, constant speed, or otherwise we can say constant velocity, the acceleration of the object is 0. Acceleration of the object is 0. Why? Because final velocity and initial velocity both are same. So during the particular interval of time, during the particular interval of the time of 3 hours and 2 hours, the velocity remains same, that is 40 km per hour. So acceleration of the object 0. What is that? Acceleration of the object becomes 0. So finally, what is the conclusion here? What is the conclusion? So whenever velocity of the object moves with constant, acceleration becomes 0. Acceleration becomes 0. Is it clear? Yes, that's all. That is a concept. Okay. See, yes. Here we have found the acceleration. So acceleration 0. Okay. Another one quantity is left. What is that? Yes, magnitude of the displacement. Is it clear? Yes. Next we will find magnitude of the displacement. So what is the magnitude of the displacement during the particular interval of time, that is 3 hours and 2 hours. Okay, what is that? 2 hours and 3 hours. Is it clear? Yes. So we have found the acceleration. Next we will move on magnitude of the displacement. Okay. Yes. So next, what is that? So I don't have space, you adjust that. Okay, there is no way. So next one, magnitude of the displacement. Okay, displacement here in velocity time graph, the displacement is also known as area, or otherwise we can say that is distance. Okay, yes. Here which is displacement, sir? Okay, here which is displacement in this velocity time graph under the third condition? Here which is displacement of the object? Yes, this portion, the shaded portion, that is denotes displacement of the object during the particular interval of 3 hours and 2 hours. The shaded portion, that is, what is the displacement of the object during the particular interval of 3 hours and 2 hours. This area we are going to find out. Is it clear? Yes. Actually, what is this shape? What is this shape? What is the shape of this one? That is rectangular shape. Am I right? What is that? That is rectangular shape. So during the particular interval of 3 hours and 2 hours, the distance covered by the object which is equal to the rectangular, which means the area of the rectangular. Can you see this clearly? Yes, this shows rectangular shape. So which is equal to rectangular, this area covered by the object which is equal to rectangular. What is that? Rectangular. Is it clear? Yes. Next I am going to find that. Is it clear? Yes. So which is equal to, here the area. Here what is the area? Here area, displacement and distance, both are same meaning. You don't get confusion. All are same meaning. Is it clear? All are same meaning. You don't get confusion. Okay. So here area, which means what area? This area which is equal to, what is that? Area of rectangle. Am I right? Area of rectangle. Okay, if you get confusion, you avoid and you mention displacement, no problem at all. Displacement, no problem at all. Okay, yes. So here displacement of the object which is equal to area of rectangle, because during the particular interval of 3 hours and 2 hours, that shows rectangular shape. Very rectangular shape. So this displacement is equal to area of rectangle ABCD. ABCD. Rectangular ABCD. Is it clear? Yes. So what is the area of rectangle formula? Area of rectangular formula. What is that? Half BH. Is it half BH or any other? Any BH. That is for area of triangle. Area of triangle. But what is the area of rectangle? That is L into B. Length into breadth. That is area of rectangle. Right? Yes, I am going to use that formula here. So area of triangle. Rectangle. Area of rectangle. What is that? Area of rectangle? Yes. L into B. Okay, L into B, which means length into breadth, that is area of rectangle. Okay, yes, I am going to take that. So, in this rectangle, which is length and which is breadth? You tell me. Which is length and breadth? Yes, this is length and this is breadth. Am I right? This is length and this is breadth. So, AC is a length, CD is a breadth. That's all. See, simple multiplication and addition, that's all. You don't get confusion. It's not a very toughest subject. Physics is a very, very easiest subject if you listen the concept, if you try to understand the concept, or otherwise it will be collapse you. Okay, yes. Look at here. So this area is equal, area of rectangle is L into B, AC is a length and BC is a, what is that? BC is a breadth. Okay, yes. So area of rectangle which is equal to length, what is that? AC, yes, AC into, this topic is broken again and again. Yes, next one, what is that? Breadth, CD, breadth value, CD. Is that clear? Yes. So what is the AC value, sir? A is here and C is here. What is AC value? Which is equal to this one. Which one? Velocity. Am I right? Yes. This AC which is equal to this one, which means velocity, because AC which is parallel to this one, velocity x-axis, y-axis. This is y-axis. This AC parallel to this y-axis. Am I right? Yes. If this value is 40 km per hour, and what about the AC value? AC value will be 40 km per hour because they both are parallel to each other. Am I right? Yes. This AC which is parallel to the y-axis. So here AC value is how much? This one. This area fully, that is 40 km per hour. Am I right? AC value how much? 40 km per hour. That is length, which means AC value completed. Okay, yes. Into multiplication symbol is there. Into CD value how much? This is C and this is D. Am I right? This is C and this is D. What is CD value? CD value how much? CD value how much? You tell me. Yes, time interval. What is that? Time interval. Because CD, this is for x-axis. The time interval how much? This is 1 hour, because the T2 value is 3 hour and T1 value is 2 hour. So 3 hour minus 1 hour, 3 hour minus 2 hour, which is equal to 1 hour, because we always subtract from larger quantity to smaller quantity. Here which is larger quantity? 3 hours is larger quantity, 2 hours is smaller quantity. So 3 minus 2, which is equal to 1 hour. So CD value how much? This CD value which is equal to 1 hour. Okay, yes, 1 hour. Can you see this clearly? Yes, that's all very simple, don't get confused. Okay, yes. So listen here, next one, this hour and hour cancel. Am I right? Hour and hour cancel each other, isn't it? Yes. Next, what is the value here, sir? What is left here actually? Yes, just this 40 kilometer is left. So 40 kilometer is what is that? That is displacement. That is displacement of the object during what interval of time? Look at here. So during the interval of 2 hours and 3 hours, what is the displacement covered by the object? That is 40 kilometer. Am I right or wrong? Yes, that is 40 kilometer. Very simple mathematical calculation, that's all. So what is the conclusion here? So what is the conclusion actually here? So during the time interval of 3 hours and 2 hours, the displacement covered by the object is just 40 kilometers. How much? Just 40 kilometers. Then what about the acceleration, sir? What about the acceleration? So during the time interval of 3 hours and 2 hours, the acceleration of the object is 0. Am I right? What is that? Acceleration of the object is 0. Because why? Because initial velocity, that is 40 km per hour, final velocity also 40 km per hour. So final velocity minus initial velocity 40 km per hour minus 40 km per hour, which is equal to 0. Am I right? Which is equal to 0. So during the time interval of 3 hours and 2 hours, the acceleration of the object is 0. What is that? Acceleration 0. But there is displacement covered by the object that is equal to 40 kilometers. Even though the acceleration is 0 at constant speed or constant velocity, the displacement covered by the object is 40 kilometers. What is that? 40 kilometers. That's all, khatam. Is there any doubts? No doubt. Okay, so very, very simple concept. Please try to understand the concept, what I am telling here. Is it clear? Yes. So the third condition, so under the velocity time graph is when an object velocity remains at constant, okay, or otherwise we can say speed at constant. Speed remains at constant. Is it clear? Yes, because here velocity time graphs are also known as speed time graphs. Speed time graph. Am I right? Yes. So whenever an object moves with constant velocity or constant speed, acceleration of the object will be 0. When the object moves with constant speed or constant velocity, not a uniform velocity or uniform speed. Okay, see, uniform velocities differ from constant velocity. Both are not similar, both are not same. You don't get confusion. That is uniform, this is constant. Is it clear? In uniform velocity, which means uniform acceleration, the velocity of the object increases uniformly. But in constant velocity, whatever the time quantity, still the object moves with same velocity, that is constant velocity. Is it clear? So there is some dissimilarities between uniform velocity and constant velocity. Okay, don't get confusion. Is it clear? Yes. So whenever an object moves with constant speed or constant velocity, acceleration of the object will be 0. Will be 0. But there is displacement covered by the object here, that is 40 kilometer. How much? 40 kilometer. That's all, very easy one. You don't get confusion. Okay, so nothing is there. Very simple mathematical calculation. That's all. Isn't it? Yes. So finally, what is the conclusion here? What is the conclusion? Okay, so till now we have seen 3 conditions of the object motion, okay, in velocity time graph. First one, what is that? When an object velocity changes at uniform rate, completed. And second one, when an object velocity changes at non-uniform rate, completed. And third one, this is when an object velocity remains at constant. That's all, khatam. Okay, it's very simple concept. So here, what is the final conclusion here? In velocity time graph, if the straight line here, which is straight line, this is straight line. If the straight line parallel to the time axis, this is time axis, or otherwise we can say x-axis, isn't it? Yes. So in velocity time graph, if the straight line which is parallel to the time axis or x-axis, then that motion is said to be, what is that? What is that? That motion, that is constant speed or constant velocity. Is it clear? Yes, that is constant. We can say that is constant velocity, or otherwise we can say constant speed. Okay, that motion is said to be constant speed or constant velocity. That's all. Isn't it? Yes. So look at here. At constant velocity of the object, okay, at constant velocity, the acceleration of the object will be 0. Whenever an object moves with constant speed or constant velocity, acceleration of the object will be 0. What is that? Acceleration of the object will be 0, but there is displacement covered by the object. There is displacement covered by the object. That is conclusion here. That is conclusion, isn't it? It's very simple. So this is equal to the area of rectangle. Area of rectangle formula, that is L into B, which means length into breadth, which is equal to length, which is the AC, and breadth CD. Am I right? So length value AC, which is equal to velocity value, that is equal to 40 km per hour. There. Next one, this CD, which is corresponding to, which means equal to this time, a time interval, that is 3 hour and 2 hour, because we have 2 interval of time. This is considered as T2 and this is T1. So T2 minus T1, which is equal to 1 hour, I have written here. So hour cancel, remaining we have just 40 kilometers. That is displacement covered by the object, or otherwise we can say area covered by the object, or distance covered by the object during the particular interval of time, that is 3 hours and 2 hours. That's all. Isn't it? Yes, very simple. So three concept completed, which means 3 conditions of the object motion in graphical method completed. In what graph? Actually, there is velocity time graph, isn't it? Yes. 3 completed. Okay. Yes. So you see, look at here. Physics subject is very easy subject. Physics actually is very easy subject. Please try to understand the concept. Okay, if you try to understand the concept, physics is one of the sweetest subject. Really, I'm telling you, physics is a very interesting subject. Okay, so if you ignore that it's a very toughest subject, I don't need to listen there. Okay, if you think about like that, it will be very toughest subject. Okay, so think positive. Whenever you start studying the physics, think positive. I can do it like that. Okay, if otherwise, really it will collapse you. Isn't it? It's very simple. Physics is an amazing subject. If you have any doubt, mention in NCERT book. Whenever you come to school, come and meet me. I'll clarify your doubt. Okay, I am here for you. I'm working here because for you only. Okay, so whatever the doubt you ask me. Okay, yes. So look at here. Till now, in velocity time graph, we have discussed 3 conditions of the object motion. 3 conditions of the object motion. Am I right? Yes. First one, what is that? Look at here. First one object, what is that? Velocity of the object changes at uniform rate. Velocity of the object changes at uniform rate. And second one, what is that? Non-uniform rate. And third one, what is that? At constant. What is that? Third one, what is that? At constant. Isn't it? Yes, very simple. Listen here, because it will be very helpful to you. I'm going to compare 3 of them. Okay. Yes, look at here. So this is velocity time graph, x-axis, and this is y-axis. X-axis we always take what is that? Time. X-axis we always take time in seconds or how whatever it is. Then y-axis we always take velocity. Isn't it? Yes. Here also, this is y-axis and this is our x-axis. Time we always take time along the x-axis and velocity along y-axis. Here also, it's a time axis and this is velocity. Isn't it? Yes, look at here. This is first condition in velocity time graph, second condition and third condition, isn't it? Yes, the first one, what is that? When an object velocity changes at uniform rate. This one. Here, when an object velocity changes at non-uniform rate. Second one. Here, third one, when the velocity of the object remains at constant, that is third one, isn't it? Yes. So whenever the object velocity changes equal amount in equal interval of time, it will be straight line. It will be straight line. Is it clear? Yes, look at here. So this is straight line. In velocity time graph, if the straight line is inclined to the x-axis, this is straight line. This is straight line. If the straight line is inclined to the x-axis, we can say what is that? We can say what is the motion of the object? We can say the object is at uniformly accelerated motion. What is that? Uniformly. The object is at uniformly accelerated motion. That motion is said to be uniformly accelerated motion. Whenever in velocity graph, in velocity time graph only, note this point, in velocity time graph, whenever the straight line which is inclined to the time axis, that motion is said to be uniformly accelerated motion. That's all. Uniformly accelerated motion, isn't it? Yes. Next, come to non-uniform acceleration. In that is the title reveals the answer non-uniform. That's not a uniform. So there will be curved line like this. That will be curved line like this. So in velocity time graph, the curved line shows what is that? The object is at, what is that? The opposite to that one. Yes, non-uniformly accelerated motion. Okay, what is that? Non-uniformly accelerated motion. Non-uniformly accelerated motion. That is also accelerated motion because velocity increases, but that is non-uniform amount, non-uniform rate. That's all. Okay, non-uniform rate. That's all. Isn't it? Let's look at here. So in velocity time graph, the curved line indicates. Note this point. This curved line indicates that object moves with non-uniform velocity. What is that? Non-uniform velocity, or otherwise we can say non-uniformly accelerated motion. That motion is said to be non-uniformly accelerated motion. Is that clear? Yes. Next, come to this one, last one. Just now I have taught that constant speed. What is that? Constant speed. Look at here. So this is constant speed. Here the speed constant. Am I right? Here the speed constant, isn't it? Yes. So this is velocity time graph. So in velocity time graph, look at here. In velocity time graph, if the straight line, this is straight line. Can you see this? This is straight line. Yes. If the straight line which is parallel to the time axis, which means x-axis. If the straight line which is parallel to the time axis, which means x-axis, we can say that object is at uniform speed or uniform velocity. The object is at uniform speed or uniform velocity. What is the acceleration, sir? Acceleration 0 here. Whenever an object moves with constant speed or constant velocity, acceleration will be 0. What is that? Acceleration will be 0, 0, 0. Keep that in your mind. Okay, acceleration will be 0 here. Isn't it? Yes, when an object moves with constant speed or constant velocity, but not now uniform velocity or uniform speed, isn't it? Because uniform and constant, okay, so both are not similar, both are differ each other, isn't it? Yes. So come to this one at constant. So note this point, very important, one more question. So in velocity time graph, whenever the straight line which is parallel to the time axis, so this one parallel to that one parallel to this one, parallel to the time axis, what is that? The object is at constant speed. The object is at constant speed. At constant speed, the acceleration of the object will be 0. Am I right? Acceleration of the object will be 0, 0, 0. That's all. 3 conditions of the object in graphical methods completed, isn't it? Yes, very simple. Okay, compulsory one question will be come to a term 1 examination from this all conditions of the object. Any one question definitely will come. Okay, yes, very simple. Is there any doubt? No doubt. Okay, shall I explain Tamil? Because you can understand more clearly. That is why. Okay, yes. Velocity time graph la namakku 5 conditions irukku. ஓகே 5 கண்டிஷன்ஸ் இருக்குது. என்னென்ன 5 கண்டிஷன்ஸ் சார்? ஃபர்ஸ்ட் ஒன், ஆப்ஜெக்ட் வந்து யூனிஃபார்ம் ரேட்டில் யூனிஃபார்ம் அதோடைய ஆப்ஜெக்டோட வெலாசிட்டி யூனிஃபார்மில் சேஞ்ச் ஆகுது. நெக்ஸ்ட் நான் யூனிஃபார்மில் சேஞ்ச் ஆகுது. தேர்ட் ஒன்று, ஆப்ஜெக்டோட வெலாசிட்டி கான்ஸ்டன்ட்டில் போகுது. அண்ட் ஃபோர்த் ஒன்று, ஆப்ஜெக்டோடைய வெலாசிட்டி யூனிஃபார்மாக டிக்ரீஸ் ஆகுது. ஃபிஃப்த் ஒன், ஆப்ஜெக்டோடைய வெலாசிட்டி நான் யூனிஃபார்மாக டிக்ரீஸ் ஆகுது. இதுதான் 5 கண்டிஷன்ஸ். இந்த 5 கண்டிஷன்ஸ் தான் இந்த வெலாசிட்டி டைம் கிராஃபில் பார்க்க போகிறோம். ஃபர்ஸ்ட் கண்டிஷன் இது, செகண்ட் இது, தேர்ட் இது. ஓகேவா? ஃபர்ஸ்ட் எடுத்துக்கோ. ஃபர்ஸ்ட்டில் ஆப்ஜெக்டோடைய வெலாசிட்டி எப்படி யூனிஃபார்மாக சேஞ்ச் ஆகிறதுனால இங்கே என்ன ஆகுது, வெலாசிட்டி டைம் கிராஃபில் இந்த மோஷன் வந்து ஸ்ட்ரெயிட் லைனில் வரும். நமக்கு கிராஃப் போட்டு பார்த்தீங்கன்னா கண்டிப்பாக ஸ்ட்ரெயிட் லைனில் தான் வரும். ஸோ இந்த ஸ்ட்ரெயிட் லைனு டைம் ஆக்சிஸ்க்கு இன்க்ளைண்டாக இருந்தது அப்படின்னா, இன்க்ளைண்டு ஓகே, இன்க்ளைண்டு விச் மீன்ஸ் ஆங்கிள் இன்க்ளைண்டாக இருந்தது அப்படின்னா நம்ம என்ன சொல்கிறோம்னா அந்த மோஷனை யூனிஃபார்ம்லி ஆக்சலரேட்டட் மோஷன் சொல்கிறோம் நம்ம. ஓகே, அந்த மோஷன் நம்ம என்ன சொல்கிறோம், யூனிஃபார்ம்லி ஆக்சலரேட்டட் மோஷன் சொல்கிறோம். புரியுதா? எஸ், ரொம்ப சிம்பிள் தான். ஓகேவா? நெக்ஸ்ட் நான் யூனிஃபார்ம் ரேட்டில் எடுத்துக்கோ. நான் யூனிஃபார்ம் டைட்டிலே நமக்கு என்ன சொல்லுது, ஆன்சர் கொடுக்குது. நான் யூனிஃபார்ம் என்ன, யூனிஃபார்ம் கிடையாது, நான் யூனிஃபார்ம் சேஞ்ச் ஆகிட்டே இருக்காங்க, அதான் நான் யூனிஃபார்ம். ஓகேவா? ஸோ இன் வெலாசிட்டி டைம் கிராஃபில் இந்த கர்வ்டு லைன் எதை இண்டிகேட் பண்ணுது அப்படின்னா ஆப்ஜெக்ட் வந்து நான் யூனிஃபார்மில் மூவ் ஆகுதுன்னு சொல்லுவோம். அந்த மோஷனை என்ன சொல்கிறோன்னா நம்ம நான் யூனிஃபார்ம்லி ஆக்சலரேட்டட் மோஷன் சொல்கிறோம். புரியுதா? எஸ். நெக்ஸ்ட் தேர்டு கண்டிஷன் என்ன, ஆப்ஜெக்ட் வந்து கான்ஸ்டன்ட் ஸ்பீடில் போகாது, கான்ஸ்டன்ட் ஸ்பீடில் போகுது. ஓகேவா? கான்ஸ்டன்ட்னா வெலாசிட்டி அங்கே சேஞ்சே ஆகலை, வெலாசிட்டி சேஞ்சே ஆகலை, கண்டினியூஸாக சேம் வெலாசிட்டியை மெயின்டைன் பண்ணிட்டு இருக்கு. ஆனால் யூனிஃபார்ம்னா என்னன்னா ஆப்ஜெக்ட் வெலாசிட்டி சேஞ்ச் ஆகுது. யூனிஃபார்ம் வெலாசிட்டியும் கான்ஸ்டன்ட் வெலாசிட்டியும் ரெண்டுமே ஒன்று கிடையாது, ரெண்டுமே டிஃப்ரெண்ட்டு, கன்ஃபியூஸ் பண்ணிக்கவே கூடாது. புரியுதா? எஸ். கான்ஸ்டன்ட்னா அங்கே வெலாசிட்டியில் சேஞ்ச் இல்லை, கண்டினியூஸாக ஒரு பர்டிகுலர் வெலாசிட்டியில் போயிட்டே இருக்குது ஆப்ஜெக்ட். புரியுதா? எஸ். அப்போ எப்படி இருக்குன்னா வெலாசிட்டி டைம் கிராஃபில் அந்த கிராஃப் என்னோட ஸ்ட்ரெயிட் லைன் இருக்கும். ஸோ இந்த ஸ்ட்ரெயிட் லைன் வந்து டைம் ஆக்சிஸ்க்கு பேரலாக இருந்ததுன்னா, எதில் வெலாசிட்டி டைம் கிராஃபில் பேரலாக இருந்ததுன்னா நம்ம என்ன சொல்கிறோம் அப்படின்னா தி ஆப்ஜெக்ட் மூவ்ஸ் வித் கான்ஸ்டன்ட் ஸ்பீட். அதாவது ஆப்ஜெக்ட் கான்ஸ்டன்ட் ஸ்பீடில் போயிட்டு இருக்கிறதா அர்த்தம். ஓகேவா? கான்ஸ்டன்ட் வெலாசிட்டியில் போயிட்டு இருக்கிறதா அர்த்தம். எங்கள் ஸ்பீடும் வெலாசிட்டி ரெண்டுமே சேம் தான். புரியுதா? எஸ். ஸோ கான்ஸ்டன்ட் வெலாசிட்டியில் போகும்போது ஆக்சலரேஷன் என்னவா இருக்கும் சார்? ஆக்சலரேஷன் 0வாக தான் இருக்கும். பிகாஸ் நீ எந்த 2 பாயிண்ட் எடுத்தினாலும் அந்த கிராஃபில் என்னவா இருக்கும், ஃபைனல் வெலாசிட்டி மைனஸ் இனிஷியல் வெலாசிட்டி, தட் இஸ் சேஞ்ச் இன் வெலாசிட்டி. ஆமாவா? எஸ். ரெண்டுமே சேமாக இருக்கனால என்னவும் 0 ஆயிரும், ஆக்சலரேஷன் 0 ஆயிரும். பட் ஆனால் அங்கே டிஸ்பிளேஸ்மெண்ட் கவர் பை தி ஆப்ஜெக்ட் இருக்குது. புரியுதா? தட்ஸ் ஆல். இதுதான் கன்க்ளூஷன், வேறு எதுவுமே கிடையாது. ஓகேவா? So remaining 3 conditions we will see in next video class, because if I take that 2 conditions it will go more another 1 hour or 1.5 hour like that. So I'm going to stop immediately this session. Okay? Yes. Remaining 2 conditions we will see in next video class. Thank you students. Bye.